दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. We discussed with isomerism the compounds having same molecular formula but different structure due to different arrangement of the carbon-carbon chain, or due to different position of the functional group on the same carbon-carbon chain, or due to different possible functional groups, or due to different arrangement of the carbon atoms on either side of same functional group, are said to exhibit structural isomerism. The structural isomerism, I have told you, CP, central, porous, force, steam, MTR. That is, you come to chain isomerism, position isomerism, functional isomerism, metamerism, tautomerism, and ring chain isomerism. The chain isomerism we have discussed in our first class. The compounds having same molecular formula but different structure due to different arrangement of the carbon-carbon chain are said to exhibit chain isomerism. Each structural form is called a chain isomer. We have discussed two examples. We have discussed butene has two chain isomers, N-butene and isobutane. Pentane has three isomers, the N-pentane, isopentane and neopentane. I gave you a homework that what are the possible structures of butane, the C4H10O. Now you see there is one O is present. So all organic compounds are either hydrocarbons or derivatives of hydrocarbon. So organic compounds having one O are four type of compounds: alcohol, ether, aldehydes and ketones. But aldehydes and ketones, this is a CN, its general formula becomes what? CN H2N plus 2O. So CN H2N plus O, it can be an alcohol or it can be an ether. So it can be an alcohol or it can be an ether. So let us take this as a alcohol first. So that is the way how you can decide what is the compound. It can be an ether or it can be an alcohol. So in alcohol, there are four carbon atoms. We can arrange the four carbon atoms in different manner and write the functional group. So we can write the four carbon atoms in a long chain like this and write the OH group here at one carbon atom. Or we can branch this carbon atom. This is alcohol, we can branch it. Where the branching begins? The branching begins at or behind third carbon atom. Always keep it in mind, the branching begins at or behind third carbon atom. So this third carbon atom is this 1, 2, 3. 1, 2, 3 is this the third carbon atom. So this is C, this is OH, and here is one carbon atom, here is one carbon atom. So you got the skeleton of two alcohols. Now saturate the tetravalence of carbon by hydrogen atoms. So while writing a structure, you have learned, write the carbon atoms in different possible carbon-carbon chain. Second, satisfy the tetravalence of carbon by hydrogen atom. Here one gone. So we'll have the structure for this C, 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 OH. So one gone, CS3. Here 1, 2 gone, CS2. 1, 2 gone, CS2. 1, 2 gone, CS2. So this is N-butyl alcohol. The common name is N-butyl alcohol because there is a OH group, it is alcohol, and all the carbon atoms in a normal chain. Now if we come to this, the skeleton we have written C, 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 OH. One gone, CS3. One gone, CS3. 1, 2, 3 gone, CH. 1, 2 gone, CS2. Now you see here. So this is also OH functional group, but this is iso chain. This is a butyl alcohol. 4 carbon atoms are there. 1, 2, 3, 4. Butyl. OH group is the alcohol, but the carbon atoms are in an iso chain. Why iso chain? Because this carbon atom is bonded with 2 equal groups. So we'll have, this is iso butyl alcohol, isobutyl alcohol. Now if you write the IUPAC name of this first one, we can write the IUPAC name 1, 2, 3, 4. 4 carbon atoms are there. It's a derivative of butane. At one carbon atom there is OL. So we'll write the name. You write first, all organic compounds are derivatives of hydrocarbon. What is the hydrocarbon here? Butane. So what has happened? Hydrogen gone. When hydrogen goes, you remove E. When hydrogen goes, you remove E. And what has happened? At one carbon atom, OH group is attached. OH group means OL. So it is called butan 1-ol. It is called butan 1-ol. If you come to this, choose the longest continuous carbon-carbon chain. Number the carbon atom such, the carbon atom having the functional group will have the lowest number. So we got 1, 2, 3. So it's a derivative of propane. This compound is a derivative of propane. At one carbon atom, OL, and at a 2 carbon atom, there is a substitution. So second carbon atom is attached with methyl. So this hyphen means 1. 1 carbon atom is attached with alcohol. This hyphen means 2. Second carbon atom is attached with alcohol. So first you write the compound. So it was hydrocarbon was propane. Now what has happened? Hydrogen gone, E gone. So hydrogen gone means E gone. And what has happened? At one carbon atom there is OL. And at 2 carbon atom there is a substitution. So we write 2-methyl propan 1-ol. So this compound isobutyl alcohol is called 2-methyl propan 1-ol. And this is a CS2OH group is called primary alcohol group, hence is a 1 degree alcohol. And here CHOH group, here these also 1 degree alcohol. Both are 1 degree alcohol because both have the same CS2OH. So both are 1 degree alcohols. So this is an alcohol has 2 functional groups that it is exhibit the butanol has 2 chain isomers. One is butan 1-ol and butan 2-ol. Now let's go to the second type of structural isomerism, P, position isomerism. So look at the definition which you have written. The compounds having same molecular formula but different structure due to what? Position. Due to position of the same functional group or unsaturation on the same carbon-carbon chain. Because if there is unsaturation also, they will have different structures, maybe different type of compounds, and functional group you may have. So compounds having same molecular formula but different structure due to different position of the functional group or unsaturation on the same carbon-carbon chain. So let's take the example of we are the position isomerism. We are discussing about the position isomerism, the compounds having same molecular formula but different structure due to different position of the functional group or unsaturation on the same carbon-carbon chain. So let's take the example of butene C4H8 because alkenes have molecular formula CnH2n, so C4H8. So we have the 4 carbon atoms, we can write in a long chain and put the double bond at 1 carbon atom, 1, 2, 3, 4. So, or we can write the 4 carbon atoms in a long chain and put the double bond at 2 carbon atom. So now by changing the position of the double bond, we have 2 structures. So this is a structure 1 is a chain isomer, position isomer of structure 2. Now if you write the structure for this, so this will be CS2 double bond CH single bond CS2 single bond CS3. So here 1 gone, so this will be CS3. Here 1, 2, 3 gone, so this will be CH. Then 1, 2, 3 gone, CH, and this is CH3. So now this is also butene, this is also butene. So they have the same molecular formula but different structure due to different position of the double bond on the carbon-carbon chain. So here if you name them 1, 2, 3, 4, so it is but 1 ENE. And if I write this 1, 2, 3, 4, then 4 carbon atoms are there, derivative of butane. At 2 carbon atom there is ENE, so the structure is but 2 ENE. So 1 butene, but 1 ENE and but 2 ENE both are position isomers. So the butene has 2 position isomers, 1 and 2, but 1 ENE and but 2 ENE. So now if you come to alcohol, let's take an example of a compound having a functional group. Let's take an example of a compound having a functional group, C3H8O. C3H8O. How many carbon atoms are there? 3 carbon atoms. And so this is a propanol. What is this? This is a propanol. So what is why? Now the molecular formula is CnH2n plus 2O. So this is alcohol. This is a formula of alcohol and it is propanol. 3 carbon atoms are there, propane and minus A plus OL, so it is called propanol. So who is the functional group? OH is the functional group. Who will be the functional group of alcohol? OH. So we can write the 3 carbon atoms in a long chain. We can write the 3 carbon atoms in a long chain and put the OH group at 1 carbon atom. 1, 2, 3. We place the OH group at 1 carbon atom. Now we can write the 3 carbon atoms in a long chain. We can put the OH group at 2 carbon atom. So 1, 2, 3. This is structure 2. So this propanol can be, we can write the functional group at 1 carbon atom. We can write the functional group at 2 carbon atom. So due to now the position is changing, because of change of the position, we are having 2 structures for the molecular formula C3H8O. Now if you write the full form, here 1 gone, CS3, then 1, 2 gone, CS2, and 1, 2 gone, CS2, OH. We get the structure for this is this. 1 gone, CS3, 1, 2 gone, CS2, 1, 2 gone, CS2, OH. Now if you come to this, 1 gone, CS3, 1, 2, 3 gone, CH, OH, and this is CS3. So you have 2 structures now. We'll now name. If you come to the common name, all the carbon atoms are in long chain, normal chain, normal way we have written. So we can write this as N-propyl alcohol. The common name is N-propyl alcohol. If you write the IUPAC name, 1, 2, 3. Why I am writing this side? Why not this? Now rule for IUPAC system, choose the longest continuous carbon-carbon chain. Second, number the carbon atom such the carbon atom having the functional group will have the lowest number. So here the first carbon atom, so OH. So it was propane. So how to name? What are the hydrocarbon? Propane. And what has happened? At 1 carbon atom, OL is there. So what will I do? I will write propane. The hydrocarbon was propane, but it's no more propane. It lost hydrogen. So when hydrogen goes, we remove E. So propan and 1 all, propan 1 all. And now if you come to this one, we can either number from either side, 1, 2, 3 or 1, 2, 3. So it is, now you see this is one group and this is one group, and 2 equal groups are there with this carbon atom. And CH, this group carbon atom is a isocarbon atom. This carbon atom is a isocarbon atom. This carbon atom is a isocarbon atom because it is bonded to 2 equal groups, isocarbon atom. Hence, and it is a 3 carbon atoms, propyl, and OH group alcohol, so its common name will be isopropyl alcohol. Now if I write to IUPAC name, it is a derivative of all organic compounds or derivatives of hydrocarbon, propane. At a 2 carbon atom there is OL, 2 ol. So the IUPAC name will be propane. Hydrocarbon was propane. So from propane we remove E because hydrogen gone, propan. Then a 2 carbon atom is attached with ol, propan 2 ol. So this N-propyl alcohol and isopropyl alcohol are position isomers. Due to different position of the OH group, we are having this compound, this functional group. So now this is CS2OH group. So this is a primary functional group. So this is 1 degree alcohol. This is a primary functional group. So this is a 1 degree alcohol, and this CHOH group is a secondary alcohol. So there is a 2 degree alcohol. So there is a 2 degree alcohol, and there is a secondary alcohol, and there is a primary alcohol. They will have different compounds. They will have different properties. They will have different physical properties, different chemical properties. If you take this and oxidize, you will get an aldehyde. If you take this, you oxidize, you will get a ketone. You will get a ketone. If you take this and oxidize, we will have a aldehyde. And if you take this oxidize, we will have a ketone. So we have two, always isomers, they exhibit different physical and chemical properties. If you take their boiling point, the boiling point will be different. They will have different boiling points. Now we'll discuss the chain isomerism, position isomerism. So now let's come to the third type of isomerism, that is Cpf Functional Isomerism. Functional isomerism. Now if you look to the definition which I have written, the compounds having same molecular formula but different structure due to, third point you will come in my definition, Cpf, due to different possible functional groups on the same carbon-carbon chain. We will have different possible functional groups. Of the same carbon-carbon, you will have different functional groups. Then it will have this. So you will have a, because of different functional groups they can have. So we can take an example here that alcohol, we can take an example, both alcohols and ether have same molecular formula, but different functional groups. Both alcohol and ether functional groups, hence exhibit functional isomerism. We can say that an alcohol is a functional isomer of ether. If a question comes in your +2 exam, alcohol and ether are dash functional isomers, or dash is alcohol and alcohol is a dash isomer of ether, is a functional isomer of ether. Like that you can have a fill up the blanks in your question paper. Now let's come. Alcohol, then what is the molecular formula of alcohol? They have the same molecular formula, CnH2n plus 2O. Somebody may question, sir, how do you got this? Are you remember? I don't remember. Children, one thing I have been impressing on you, that the more you forget, more you remember. If you remember, you will definitely forget. What? All organic compounds are derivatives of hydrocarbon. What is the hydrocarbon? RH. we are writing an alcohol. What is the functional group? Functional group is OH. So I get ROH. What was my R? RH is what from alkane, have molecular formula CnH2n plus 2. And what has happened? A hydrogen gone. A hydrogen gone. What this will become? This will become CnH2n plus 1. And what has happened? And OH is attached. The functional group is alcohol, OH. So then what the formula will be? This will be CnH2n plus 2O. So this is the molecular formula of alcohol. So I don't remember the formula. The moment say alcohol, I can all organic compounds are derivatives of hydrocarbon. I write hydrocarbon RH, the functional group is OH. So I remove H and put OH. So I get ROH. So R is RH is CnH2n plus 2. So R is CnH2n plus 1 and OH. So CnH2n plus 2O. So now let's take an example here, functional isomerism. Ethers and alcohols, they have the same molecular formula CnH2nO. So what has happened? What is ether? Ether has a molecular formula ROR. This is ether. ROR is called when one oxygen atom is bonded to two alkyl groups on either side, it is called ether. So both the alkyl groups may be same or both they may be different. If they are same, it is called symmetrical ether, and if they are different, it is called unsymmetrical ether. There can be symmetrical ether and unsymmetrical ether. So let's take the example of C2H6O. Let's take the example C2H6O. What is this? 2 carbon atom. So if you come to an alcohol, it is ethyl alcohol. If I write as an alcohol, we can write CCCOH. This is an alcohol. Now we want to put it ether, so we'll put the O in the middle and write the 2 carbon atoms on either side. So this becomes an ether. So this is an alcohol and now this is an ether. So they have the 2 functional groups. Here there is a functional group and there is a 2 functional group. Hence they are exhibiting ether and alcohol exhibit functional isomerism. Now if I write the hydrogen atom, this will be CS3, CS2, OH. So this is ethyl alcohol. This is ethyl alcohol and IUPAC name is ethanol. We can have the IUPAC name as ethanol. Now if you come to this is CS3, this is O, this is C. So ROR, ether. So this is methyl, this is methyl. So we'll say 2 methyl groups. So dimethyl ether. The common name is dimethyl ether. If you come to IUPAC name, choose the longest continuous carbon chain. So if you take this as alkane and here is the substitution attached. So CS3 oxygen, it is called methoxy group bonded to what? Methane. So this is called methoxymethane. The IUPAC name of ether is alkoxyalkane. So this is methoxymethane. So now what will you say? We will say here that ethyl alcohol, we can conclude ethyl alcohol is a functional isomer of dimethyl ether. Dimethyl ether. Functional isomer of dimethyl alcohol and ether, they exhibit functional isomerism. Now if we will come to second class of compound, both aldehydes, another example we can take here, both aldehydes and ketones have same molecular formula, but different functional groups, but different functional groups. Hence, an aldehyde is a functional isomer of ketone. Hence, an aldehyde is a functional isomer of ketone. What is an aldehyde? RH is the alkane. If you remove H, put the functional group COH, this becomes aldehyde RCOH. So the COH group is the functional group in case of aldehyde. Now if you take RH, from RH, if you remove H and put COR, so you get RCOR and it is called ketone. So you'll get the COR. So you'll this RCHO is aldehyde and RCOR is ketone. So let's take an example. An aldehyde and ketone means, now if you take a ketone has to have 3 carbon atoms. A ketone, 1 carbon, 3 carbon atoms. So a ketone has to have 3 carbon atoms. A ketone has to have 3 carbon atoms. So you have here 3 carbon atoms. So you have to take an example of, so both they have the general molecular formula CnH2nO. Both aldehyde and ketone have the general molecular formula CnH2nO. So you take C3H6O. C3H6O. So we can write the 3 carbon atoms as aldehyde, CCOH as aldehyde, or we can write this as a ketone, RCOR, CCOC. We can write this as an aldehyde, RCOH. So C 3 carbon atoms, we make the last carbon atom the functional group, and in a ketone these are carbonyl group. CO group is called carbonyl group. When a carbonyl group is bonded to 2 alkyl groups, it is called ketone. You have read all these things in your organic chemistry at the beginning. So now if I put the hydrogen atoms here, this is CS3, CS2, COH. This is 3 carbon atoms are there, propane, and CHO group is aldehyde group. Aldehyde group is called Al, so it is called propanol. This is called propanol. And here if you write the hydrogen atoms, 1 gone CS3, then CO, then 1 gone CS3. 3 carbon atoms are there. So your derivative of hydrocarbon propane. So how the ketones are named? Alkane minus E plus ONE is called alkanone. Is called alkanone. So here how many carbon atoms are there? 3 carbon atoms are there. So it is a propane. Now hydrogen gone, E, and ketone. Ketone means ONE. So it is called propanone. It's called propanone. So this is a compound is called as propanone. Propanone. So this propanol and propanone is called as the functional groups. Now if you write their common name, alkyl aldehyde. What the name is? Alkyl alcohol, alkyl aldehyde. So here propyl and it's propionaldehyde here. So propionaldehyde. So here you will come to this CH3CO CH3. It is ketone. Its name is called acetone. Its common name is called acetone. So children, this is a question I am giving you. In my next class, I will ask you why acetone is called acetone. CH3CO CH3 common name is acetone. Propanone is acetone. My question to you in my next class, while I am discussing to you the functional Cpf, that is metamerism, and other 2 types of isomerism, I will be asking you this question. There is a question I am giving you. Why acetone is called acetone? Why acetone is called acetone? Why acetaldehyde is called acetaldehyde? These are the questions. We say CH3CHO is called acetaldehyde, common name. Why it is called acetaldehyde? As CH3COC is called acetone. Now it's a common name. Why common name? Why a name is given to you? Why this name is given to acetone? Why? Where from this comes? So this is a question I am giving you. So next class I will be discussing to you the CPF I have discussed. I will discuss to you MTR, metamerism, tautomerism, and chain ring chain isomerism. So you can subscribe my channel RN Panda Chemistry, and then the moment I put these other two, this class onto the YouTube, automatically it will go to you. So just subscribe the channel and wait for the next class. So in third class, class 3, we will be discussing the metamerism, tautomerism, and ring chain isomerism. Thank you so much.